While things are coming up, let me just thank the organizers for giving me a chance to come and speak here today. So I'm just going to talk a bit about some of our experiences using Python in kind of like graduate courses for data science, both at the master's and hopefully in the future at the PhD level. Now I'm very lucky. I have the distinct pleasure to have worked in Python since 1997. So I've been working on this thing for a long time. But I really felt, thinking about this talk, thinking about my paper, that I had to start with an apology, right? So there's just so much wonderful stuff that people have worked on in the Python community that just make many things in data science, education, research so much easier, better, cooler. There's just no way that I could really do justice to it in 15 minutes. So I'm kind of gonna pick and choose the things that I use, kind of things that I work on, and all that I can do is beg your forgiveness. If there's a library that I missed, don't be mad at me, but please tell me. And in fact, I've already heard things at this meeting about wonderful things, like I heard Beaker earlier today, which sounds very exciting to me. Now, as an educator, and as the person giving the very last talk of the sessions today, I want to make sure people are awake, so I'll throw us off with a pop quiz. Is everybody awake now? Okay, ready? Okay, so it's easy. So how many people here would call themselves data scientists? Okay, good. How many people here have taught others data science in a classroom setting? Good, glad there's a few of you. Okay, how about mentoring data scientists in a more informal setting, like at a company, this kind of thing? Good, a bunch of you, wonderful. Now here's the hard one, ready? Okay, you ready? What is data science? There you go. So we really use this new term, right? We really use this new term. So I saw this before. This has appeared in previous talks. There's this Conway's data science Venn diagram, right? Where really there are these three things. There's the math skills. How do you do all the underlying statistics, things like that. The hacking skills. How do you actually get these things to scale to large data sets? And then last, but certainly not least, is knowing something about the data, right? Knowing something about the actual domain that you're interested in. Now, at WPI, we have this graduate program, and our design of the program is pretty faithful to this kind of idea. So it's actually interdisciplinary between the computer science department, the mathematical sciences department, where I live, and the business school. Now, this ends up being this wonderful interdisciplinary environment for the students, or the challenge, right? So there's a big educational opportunity with these graduate students. And it is that they come from amazingly different backgrounds. There are some students who are brilliant mathematicians. They haven't really programmed so much. There are some students who, hack the Linux kernel, but maybe they don't know quite as much mathematics. So then the question becomes, when these students enter the program, how do you get them all to have kind of a common baseline of expertise, a common baseline of knowledge, to really understand what the rest of the program is, to understand what they want to do in the program? So one of the classes that I teach is Introduction to Data Science. And now here's the description of the course in the WPI course catalog. Okay, so this provides an overview of data science. And we cover data collection, integration, management, modeling, analysis, visualization, prediction, informed decision making, as well as security and data privacy. And databases, data warehousing, statistics, data mining, data visualization, high performance computing, cloud computing, business intelligence. And I'm tired just saying it, right? So the question is, how do you do that? How do you do that in a semester class? It even goes further, right? We're worried about communication skills, presentation skills. And then really the part of the course that gets me up in the morning, that makes me very excited to teach this course, is the hands-on projects and case studies. For me, it is extremely important that you have these students really get their hands dirty with the data, right? So how do we pull that off? I bet everybody knows the answer. Python, right? We use Python in this course so that we can have the students really focus on the appropriate learning objectives at each part of the course, while at the same time be able to solve interesting problems, not always have to worry about toy problems. Now, I've heard this 100 times at this conference, right? And one of the really wicked cool things about Python is the IPython notebooks. And we use those in this course. And we actually use these both for the assignments. We actually provide the assignments to the students in IPython notebooks. They do their work in the IPython notebook, and they can actually submit the results in the IPython notebooks. And this is just very pretty. They have access to LaTeX, Markdown, their code, the results, all in one place. I also want to give a shout out to the nthought guys. The fact that nthought has this very nice canopy distribution that you can install on Windows, any place you like, and with a very generous academic license, makes it very easy for the students. So that's definitely one of the very important pieces of this whole thing, is the ability to have IPython notebooks. Now I'm going to go through, just kind of tell you about some of our case studies, and just kind of show you how Python factors into them. So case study 1 is really about getting data, right? How do you go off and gather data about the world, take measurements? And what we choose to do that is the Twitter streaming API. Now, one of the reasons we do this is to kind of get the students to kind of see, some of the issues with data. What happens when your API calls timeout? What happens when you're rate limited? What happens? All these kind of weird things that happen with real data. Now, fortunately, beautifully enough, there's a very nice Python library for this. It's Python Twitter, which gives you a very nice API, a very nice interface in Python for going off and gathering data from the Twitter streaming API. And then there are books written on these kind of things, and there's this book which you actually have the students read about going off and doing this, right? So this is a very nice experience for them. It gives them kind of a real experience getting data that a data scientist might want to look at. And once they have data, they want to start playing with it. So the next data set we have them work with is the Movie Lens data set. For those of you who maybe don't know what this is this collection of numeric movie reviews, 1 to 5. For users going off and saying how they thought about particular movies. And what we want to do with this is start introducing some of the Python stack along with the data science ideas. And this is where they start learning about NumPy and where they start learning about Matplotlib. But most importantly, and I know, is Wes here? I don't know if Wes is here. But most importantly, this part is pandas. I mean, pandas makes it so nice for pandas makes it so nice for the students. They can go off and do very beautiful data manipulations, very easy. And in fact, this particular case study is profoundly inspired by Wes's book, which actually was required reading for the course. Now, I'm not going to show a lot of Python code today. This is more about how Python gets used. But there is one thing in pandas that I try and encourage the students to use that makes their lives so much easier. And it's this idea of pivot tables. Right? These are just these beautiful things in pandas that let the students ask very deep, interesting questions of the data. Do a lot of very deep, interesting data data mangling without having to write a whole lot of code to do it. So once they kind of learn this paradigm of using pivot tables to understand the data, they're off and running. And they can actually do many kinds of beautiful things with the data without having to know a lot of programming, without having to write a lot of code. Okay, good. So now they've gathered data. They've done some preliminary kind of understanding of the data. Now we want to start at least introducing them to machine learning. Now, there are later courses they take where we go into this much more deeply. But the idea here is we want to get them started about thinking about kind of the things that machine learning is good at, maybe the things that maybe machine learning isn't so good at. So in this case, we use this movie review database. Now, this is similar to the previous one. It's about movies. But for the Movie Lens database, they get numbers. A user gave it a 5 or a 4. For this problem, they're given just raw text reviews. Right? Now, people who do natural language processing, this is not trivial stuff, right? They are really starting to experience the kind of issues that people run into with real data. How do you generate features? All these kinds of things. But again, I'm going to sound like a broken record. Python comes to the fore, and we have scikit-learn. Right? So scikit-learn provides many pieces that make this much easier to use. It provides the term frequency, inverse document frequency class, which makes much of the feature generation much easier for the students. And it provides a vast array of algorithms that maybe at this point they don't understand the mathematical details of, but they get a chance to see how they work and maybe more importantly how they break. Okay? So good. So now we've done data gathering, we've done data mangling, we've done a little bit of machine learning. Now we want to scale it up. And so we start having the students work on Hadoop. And now we present them with a much bigger data set, the Yelp data set challenge. There's Mr. Job. Right? So Mr. Job is a very nice kind of, Hadoop, both Hadoop API and Hadoop simulator, right? So you can actually run a Hadoop job just on your laptop to kind of see how things work, get experience with the interfaces. And then if you want to scale it up, this also provides you an interface for doing this stuff in a distributed fashion. Okay? So very good. So now, the idea here is to get these students to start understanding data science. Python happens to provide all of these wonderful libraries to kind of take away some of the grunge work for them, that they can go off and focus on their particular, their particular learning challenges. Now, there's a downside. There's actually a downside to Python in this domain. And unfortunately, it can be a little too good sometimes. And so this is another class that I teach, which this thing is keep doing this. It can be a little too good sometimes. And sometimes you'll have these students doing their homework by way of Google. Right? And they go off and they want to learn about, I don't know, ANOVA tables or something. And they go off and they Google and they say, hey, yep, here's a Python program that will generate an ANOVA table for me. So you do have to be a little bit careful when you're using such a powerful tool in teaching that the underlying ground rules are well understood. That the students understand what they're allowed to go off and use a canned routine for and what they're responsible for writing themselves. So what I often do in classes is I actually collect their code. Now be careful. I'm not collecting their code to grade their coding style, though if they do unit tests, I do like them, right? The idea is just to make sure that they are, the parts that they're supposed to be writing in detail, so they understand the algorithm very well, that they are actually doing that. Now, good. Now, once you have these students trained, you actually want to do other kind of things with them. And so, I'm a mathematician, and I'm mainly interested in, data science, semi-supervised and unsupervised methods as applied to cyber defense. I'm really interested in problems like, nonlinear dimension reduction, these kinds of things. And once I have students who have been through this training already, it is a very short step for them to start doing research with me. And again, this is well supported in the Python community, right? There are just many libraries that are very helpful getting these students, getting them bridged between their classwork into the space where they're working on their own research problems and developing their own code. So there's, I do a lot of work in convex optimization, so there's very pretty convex optimization libraries in Python. The anodes out there for doing deep learning. Graphical models, there's many libraries for doing very pretty things with graphical models. Statistical modeling. And one thing that I always enjoy, I really enjoy kind of the visualization, kind of the mathematical visualization side of these problems. And there was a very pretty talk on Boker, earlier in the conference, Seaborn. And actually one that I use an awful lot myself is Mojave. Okay. So, finally, when you actually want to scale these things up onto large computers, there's MPI bindings, there's also, CUDA bindings for doing GPU, and all this lives, all these libraries, all these ideas can be used by students who already have this Python training. So it's a very nice kind of, step-by-step process for them, originally learning the language, originally learning the ideas with it, having these libraries as a bridge so they can start doing their research, and then they go off and start writing their own code and hopefully contributing to the community. So that being said, I think I'm just about done with my time. So let me just thank the Data Science Steering Committee at WPI, without whom all this would not have been possible. Let me also thank you guys. Let me thank the scientific Python community. And I guess with that, I'll take questions. I can wait. I'm last. And you guys don't get away without questions. Go ahead, Katie.
So do you feel like the students all take away enough information to go on and be useful in research? You sort of mentioned that some of them do. What would you say the percentages you assess?
Oh, well, okay. The percentage is hard to say. Let me answer a different question.
All right.
Let me answer a different question. Right? So, the idea is, how do you increase the probability that they'll be successful in their research, right? So there will always be students who come and maybe they don't want to do it, right? That's not really, they thought they wanted that out of life, but they really don't, right? But this idea of actually having them learn Python early in their career, and then having a path that they can go through from the very beginning to their PhD, say, I think actually maximizes the probability of success. It doesn't make it for sure. We all know graduate school is a hard thing, right? But it really enhances the probability of success, right? And especially kind of this bridge to them getting into their own research, right? So you have this kind of bulwark of libraries that let you solve interesting problems. So you become passionate about what you're working on, and then that goes off into your own work. Other questions? I can wait.
So on the technical side of things, you said that you were having students submitting notebooks.
Yeah.
Are you doing that through some of the tools that people have been building, like NB Grader, or are they?
So you've caught me. No. so no, not yet. Not yet. That's why I come to conferences like this, to learn about such wonderful things.
Oh, the creator of such wonderful things is over there.
Yes.
I want to talk to her later.
Other questions? Well, thank you very much for your attention.